All right, let's jump right into today's explainer. If you write code, you already know it can honestly feel like a constant battle against chaos. It's just a daily struggle to keep your application from crashing all over the place because of unexpected data. But there's actually this silent mechanism working totally behind the scenes in Java, and it acts like this reassuring, warm blanket for your code. Today, we're pulling back the curtain on Java's hidden default constructor. We're going to see exactly how it protects you from the incredibly harsh realities of raw computing. Let's unravel this mystery.
So to really appreciate what Java's doing for us here, we kind of have to look at environments that absolutely do not hold your hand. If you've ever written anything in C or C++, you know the cold, harsh reality of uninitialized memory. I remember this one time spending hours, literally hours, tracking down a bug where a player's score was showing up as like -2 billion. And why? Because I declared a variable, completely forgot to assign it a starting value, and the computer just handed me whatever random garbage data happened to be left over in that RAM slot from some totally different program. It could be -32,000, some random hex code, just absolute nonsense. It's unpredictable, and frankly, it's dangerous. But step into Java, and that harshness just disappears. You declare a variable without a value, and instead of pure chaos, you get these safe, clean defaults: 0, false, null.
Which naturally begs a pretty fascinating question. If you didn't actually write the code to set those variables to 0 or false, how on earth did they get that way? It's kind of like waking up to find your incredibly messy room perfectly organized. You know for a fact you didn't do it. In programming terms, when you type new player to create an object, but you haven't explicitly told Java how to build that player, how does it seamlessly set up your memory when you aren't even looking?
Okay, let's actually look at what this unseen caretaker is doing. Imagine we're building a game character. We declare an integer for health, a boolean for is alive, and a string for name. Now, in a harsher language, like we just talked about, checking that health right after creation could instantly crash your game because that leftover RAM noise just happens to be some wild negative number. But Java flawlessly initializes this object's state. It guarantees that health starts cleanly at 0, is alive safely defaults to false, and the name is peacefully set to null, literally 0 leftover garbage. It's this foundational guarantee of stability that you can absolutely always rely on.
To really conceptualize this, think about a freezing winter night. You're asleep, you kick off your covers, and you're exposed to this freezing draft. But silently, a caretaker walks into the room, pulls a thick, cozy, warm blanket right up over your shoulders, and just walks away. You never ask them to do it. You only even realize it happened when you wake up feeling safe and rested. That exact feeling of unprompted, automatic protection, that is exactly what Java does for your objects. It steps in, handles the raw, messy reality of memory allocation completely so you don't have to.
All right, let's unveil the technical mystery here. Who is that unseen caretaker in our warm blanket analogy? Well, it's the Java compiler. And the warm blanket that it wraps your code in is called the hidden default constructor. When you instantiate an object, but you haven't actually bothered to write a constructor method in your class, the Java compiler looks at your code and says, "I got this," and steps in. In total silence before your program ever even runs, the compiler modifies your code right behind the scenes. It silently inserts a no-argument constructor on your behalf, doing all this heavy lifting that you probably didn't even realize needed to be done.
Here is the exact behind-the-scenes procedure this hidden code executes to make sure your objects never freeze or crash. First up, it allocates the precise amount of memory needed, carving out a nice, safe space in the RAM. Second, and this is a brilliant little architectural detail by the way, it invokes super. It actually reaches up the inheritance chain to guarantee that the foundation of your object and any parent classes it relies on are fully constructed before it even thinks about moving forward. Because, you can't build a house without a foundation, right? Java ensures that foundation is perfectly laid. And finally, step 3, it initializes all your attributes to those safe defaults, instantly, invisibly. It guarantees stability from the very first millisecond your object even exists.
But here is the catch. The crucial point is understanding when this warm blanket is applied and when it suddenly gets pulled away. When you write 0 constructors yourself, the compiler steps in. Awesome. But the very moment you write a custom constructor, let's say you demand a specific health integer has to be passed in when the object is created, the compiler steps back. Just like when you grow up and demand explicit control over your own life, that silent safety net just vanishes. The compiler assumes, okay, you're ready to manage your own memory state. If you try to create an object without arguments after doing this, Java is not going to silently fix it for you anymore. You get a compile error. The warm blanket is gone, and the responsibility is entirely yours.
So, when you step back and look at how all of this builds together, it is just a brilliant piece of software architecture. Java prevents the absolute chaos of garbage data by guaranteeing that fields are initialized as safe defaults, and it does this entirely because the compiler silently inserts a default constructor anytime you leave one out. It works 100% behind the scenes to ensure absolute object stability. This is a system fundamentally designed around developer protection and code safety. I mean, it has literally saved us all countless hours of debugging bizarre memory issues.
We've seen how beautifully Java protects us when we just let it. But as your programs get more complex, you are inevitably going to need to write custom constructors. You're going to need to take the reins. So I want to leave you with this question to think about. When you take explicit control of your code and you start demanding specific initialization, are you truly ready to give up that warm blanket? It's a really delicate balance between accepting Java's silent care and stepping up to manage your own complex object states. Thank you so much for joining me on this explainer, and hey, happy coding!